As humans become more familiar with technology, more machines are created. However, factories and the excavation of minerals to create these machines produce carbon dioxide, which leads to many different problems. One of which is ocean acidification, which has been shown to devastate fish and other forms of sea life. Our aim with this exploration is to find out how detrimental ocean acidification is to marine life and coral reefs, particularly the Great Barrier Reef.
Deloitte Access Economics has estimated the value of the Great Barrier Reef to be $56 billion, with an economic contribution to Australia of $6.4 billion per year.
The Great Barrier Reef is a valuable wonder of the world, but is disappearing at a rapid rate. In our investigation, we will discover ways to reduce the rates of ocean acidification to a minimal percentage. Ocean acidification is a growing problem in our modern society that has become so dependent upon gas, electricity, and a wasteful mindset. Since the beginning of the Industrial Revolution, the release of CO2 due to man-made activities has increased the amount of CO2 concentrations in the atmosphere. With the lack of environmentally friendly legislation, laws, and practices in our society, the biochemistry found in oceans is changing and evolving in a negative manner. Marine life requires a particular level of pH in order to maintain the natural biochemistry needed to support and maintain a healthy ecosystem. This graph is an extrapolation of current and previous records, along with a projection of the trends. For millions of years, the pH of seawater has been around 8.2. However, as a result of the Industrial Revolution occurring, the pH levels of seawater had dropped below 8.1 in the time span of 200 years. This being a whopping 25% increase in ocean acidity in a short period of time. If these trends continue, pH levels will continue to drop at exponential rates, and as a result, the degradation of marine life occurring. Let's take a look at the Great Barrier Reef, which has been affected by ocean acidification. Ocean acidification has been shown to affect sea surface temperatures, including the Great Barrier Reef's temperature. As dissolved carbon dioxide levels gradually rise, so do the temperature. This is an exothermic process which emits heat, thus raising the temperature of the reef surface. Warmer temperatures also encourage the process of coral bleaching, which will be discussed later in the video. As more carbon dioxide is released into the atmosphere, some of this dissolves in the ocean, forming carbonic acid and lowering pH levels. This changing chemistry is slowing the calcification rates of corals and other calcifiers. Although this graph illustrates that slightly higher temperatures than average allow calcifiers to have a higher calcification rate, studies have shown that calcification rates could decrease by 30%, which will be harmful to all life that live in coral reefs. This is due to the fact that drastic rises in temperature would slow the process of calcification. There are many fish species which require coral to survive. Coral reefs are like an ecosystem which are home to many species of fish. 1/3 of all saltwater fish species have lived within a coral reef before. Without coral reefs, many fish would not be able to hunt for food or have a place to live in. According to the graph, about 57 species of fish regularly feed or dwell in coral reefs. This means that 57 species of fish would be affected by the rate that coral reefs are disappearing at, which would result in the extinction of these species. To prevent the Great Barrier Reef and oceans from becoming more acidic, we should reduce our carbon emissions. Europe has already made attempts to reduce their greenhouse gas emissions, and they have already decreased their output by approximately 22% since 1990. Some effective policies that Europe has introduced include using renewable energy, improvement in energy efficiency, and reduction of carbon dioxide emissions from cars. After this exploration, we understand that ocean acidification is a problem affecting the Earth, which also affects marine life. We realize the importance of reducing carbon dioxide output. We can achieve this through using renewable energy sources, using more energy efficient technology, recycling, and etc. If we continue to output carbon dioxide at the current rate, ocean acidity will increase by a large percentage and will endanger more marine species. If we want the oceans to remain stable, we should treat them with respect and endeavor to reduce carbon dioxide output.